Ladies and gentlemen, now time for us to welcome on board our next keynote speaker today, and that is the Chief Evangelist, Intel Software, Mr. James Reinders. And please welcome with a loud round of applause, the Chief Evangelist, Intel Software, James Reinders, for the keynote address.
Well, good morning. It's wonderful to have all of you here today. As I said, my name's James Reinders. I work out of the Portland, Oregon office of Intel, where I've been privileged to work for almost 27 years now in HPC and software tools. And I'm really excited to be here to address things. The first time I came to India was in 2004, and a lot of things have changed since then. In 2004, we were on the advent of the age of multi-core processors. Very few people knew what parallel programming was, and a great deal has changed. And so I'm very excited that we're bringing this conference to you today. I've been the technical chair at looking at the content, the direction of every presentation from Intel that you'll see today. We've held these conferences in other countries as well, and I've overseen that everywhere. The one thing I can tell you is we have amazing experts here today to present content to you. I'm going to give you a flavor of some of what I think about when I think about the challenge of doing parallel programming, being a software developer in this era of ubiquitous parallel computing. I'll give you a little flavor of that and then encourage you to really engage the experts that are here today. It's a great privilege to be here with so many people that can share my excitement, our excitement with you. You know, it's if we take a look at the progress of computers, here's a diagram from the top 500 list. It shows the progress of the performance of computers on the top 500 list. It has three lines. The bottom line is the performance of the number 500 supercomputer in the world. The middle line is the performance of the number 1. And the top line is if you add up the performance of all of the top 500 computers. And this is a logarithmic graph. And it's been amazingly steady at growing. Now, as much as I'm excited about Moore's Law, one thing that really excites me about parallelism is that the rate of progress of supercomputer performance has exceeded Moore's Law consistently. And there's one reason for that. In addition to having Moore's Law, we've applied parallel computing. And this is now a trend that we'll see in the entire industry. The ability to outpace the performance that's given to us simply by the progression of the density of transistors, which is Moore's Law. So it's very exciting to me that the power of parallel computing is that we can accelerate the rate of performance gains. And that gives us enormous opportunities in a broad array of areas. We're really fueling discovery, if you will, in many, many different areas. Now, one of the things that I've done in my career was help architect ASCII Red, which was the first teraflops machine in the world. And ASCII Red would have filled this room with a little bit of space left over and consumed 850 kilowatts of power in order to deliver 1 teraflops of performance. The Xeon Phi product line delivers that in a few hundred watts. And you'll hear later today some things about the next Xeon Phi, the second generation, and it's able to take us to 3 teraflops, again at a few hundred watts. And I can hold it in my hand. That's the progress of compute power. And then, of course, Charlie talked to you about what we're able to build out with systems like that and push into the hundreds of petaflops at power rates like 13 megawatts, which is it's just amazing to me. And parallelism drives that. Now, as software developers, we have the challenge of helping program these. As Charlie was relating about Matthew Gravy, the French student who we were able to award the CERN internship to. Now, Matthew took this brain simulation code from 45 hours to under 9 minutes, just 8 minutes and change. And he emphasized that it was his brain That was the most important tool he used. And I can't say enough about the importance of investing in yourselves, your knowledge of parallel computing. So there's no magic out there. There's not going to be a magic tool that adds parallelism to a program. It's not going to happen. There's not going to be an auto-parallelizing compiler. People have looked for it for a long time. It's actually my area of expertise, of deep expert in compiler technology. Compilers are fantastic at packaging parallelism. They cannot discover it or do algorithmic transforms for you. So it's really important as software developers to understand how to figure out where the parallelism is in your application, figure out what the best approach to exploiting it is, and then understand the best techniques. We're going to have classes all day long. All this afternoon, we'll have great speakers this morning, and then classes in the afternoon that help fill in some of these gaps for you. Now, tools can help, but tools can't do everything for you, so invest in yourselves. So, with that, I thank you. Like I said, I'll be in the Ask the Experts area later. I'm around all day. I hope to get questions from you then. We're going to keep the program moving now and move on to Professor Muna's talk next.